All right, everybody. Thanks for joining me for this pop-up session today, focused on the unfolding and unfortunately just beginning long duration, what is likely to become historic heat wave across much of California and frankly now extending into other states, including Oregon and potentially Nevada as well. So this event, the reason that I'm having this session, and I was again originally going to keep it to 30 minutes, but because I'm starting early, I'll probably speak for the better part of an hour still, so I don't miss the folks who are going to join a little bit later on the half hour, is because this event just keeps ramping up in terms of expected duration and peak intensity in many areas. And also because already we're seeing a number of dangerous wildfires that have broken out just on day one of what is now likely to be a 7 to 10 day long event, during which the fuel and flammability, fuel dryness and vegetation flammability will almost monotonically increase throughout the event. And again, we're seeing some problems already on day one. Some fairly extraordinary statements out of the local Weather Service offices right now, including some watch and warning products that are of a duration that I don't think I've seen before. Right now, the Weather Service office in San Francisco extended the red flag warning for some areas from today through Friday of this week. I am not too familiar with Northern California red flag warnings excuse me, that have lasted more than 2 consecutive days on that many occasions, particularly in July. If you are going to have a long duration red flag warning in Northern California, that's usually going to be an autumn offshore wind type event. But you know, this is one of those things that is really pushing the boundary of what we've seen before this time of year. Also, maybe even more notable is that these excessive heat warnings have been extended all the way into next week, next Tuesday. Again, it is very unusual. In fact, it may be one of the longest warning products that I'm aware of, having been issued by the Weather Service. Other than some river flood warnings, of course, you can get rivers that flood for a couple weeks at a time. So I'm not sure that I've seen excessive heat warnings for more than 7 consecutive days, as they are now in effect for portions of California. So this event is notable for really across a number of dimensions. Probably the one I think that's really going to be most notable in the record books and for its human health and wildfire related implications is just its incredible duration. This thing is going to stick around for a long time, and there will be no a quick resolution to it, even when it does begin to die down eventually. It's just going to very slowly fade away to merely above average temperatures, down from record breaking. And it's going to take a full 7 days even to get to the point that we're below widespread record breaking temperatures. So again, today was day one and not the hottest day of this event in most places either. An event that may last for 7 to 10 days, especially across inland areas. Your mileage may vary at the immediate coast. This is not going to be a super extreme heat event in San Francisco, as I mentioned earlier, or coastal LA, although it is going to be notably hot in those places. But where it is really going to be extraordinary is once you get inland, the Central Valley, the foothills surrounding the Central Valley, the northern mountains, the Sierra Nevada, the inland deserts of Southern California, and the higher elevations along the Central Coast, so the high desert and the low deserts. All of these places are going to see a period of exceptionally long extreme heat, and that is where some of the impacts are going to arise. So many of you will have experienced individual days, in all likelihood, especially in places like the Bay Area, that were hotter than we're going to see at the peak of this heat wave. But I'm not so sure that really any of us will have seen this many days at this sustained level of heat, both daytime and also, as I previously mentioned, importantly, nighttime heat. Many places, if not most places, away from the immediate coast may not drop down much below 70 degrees at any point, including the middle of the night for 7 to 10 days. And in some parts of the thermal belt, so we're talking about the hills and foothills between about 500 feet up at the low end and maybe a few thousand feet, 3,000 to 4,000 feet on the high end, may not drop below 80 degrees for that same week, and there may even be some spots that stay in the 80s on some of the hottest nights, not getting much below 90 degrees at night. Granted, this isn't going to happen in Sacramento or the heavily populated areas, but in some of the peak of the thermal belt, there will be places that really don't see temperatures much below the mid-80s at any point in time for the next week. The reason I raise that is for the folks who live there, that's a big problem, particularly because some of these places are places where A, folks don't necessarily have access to air conditioning, and that becomes dangerous after a few nights that hot. B, some of these places are the locations where PG&E is shutting off the electricity and in the form of public safety power shutoffs to prevent wildfire ignitions during the initial windy portion of this heat wave. And because even absent that, the cumulative overnight warmth, the degree to which vegetation will progressively become drier even at the middle of the night, even at the coolest and moistest part of those overnight hours, is going to be rather extraordinary. And that's going to result in effectively 2 to 3 weeks worth of peak season fuel drying in just over the course of just a week. So we're going to see vegetation moisture levels jump up from slightly drier than average conditions in a lot of places to start off July to some of the driest peak July vegetation conditions we've ever seen in some parts of Northern California. This is exactly what I was hoping wouldn't happen this year because of all of the low fire activity and the abundant growth of grass and brush over the past couple of years because of the wet and comparatively mild conditions that we've seen. But now that all of that vegetation is curing, those herbaceous fuels, meaning essentially grasses, particularly at lower elevations, we're sort of off to the races, as they say. And there have been multiple large fires that have erupted in and near some populated areas in northern and central California today. In fact, even since I began this live session, I'm becoming aware of yet another one. So this session is going to be a mix of monologue and map and video camera satellite imagery showing a little bit of a reflection on the events at hand, and I'll probably be having some additional live sessions as we go through the week. I do have to do my other work. This is the problem, is now there appears to be almost no time of year when a climate scientist who studies extreme events can actually do science to study those extreme events in a formal context and write code and plot figures and write and revise manuscripts. I'm in that last phase right now, but should probably be working through the week, through the holiday. You'll probably see me live a few times between now and then as I frantically try and wrap up those revisions and keep everyone up to date on this heat wave. So the long and the short of it is that this is not going to be a short event. And the problem is going to be, it's just going to be day after day after day of heat. The other update, in addition to this event lasting maybe a little bit longer and potentially just sort of transitioning into potentially a secondary or even tertiary wave of anomalously hot temperatures down the line, is that the peak of this event in some places may end up actually being close enough to threaten at least a few all-time high temperature records in some places. So I initially said that we'll have to wait and see, that it didn't look extremely likely that this would break all-time records. You still can't look at Apple weather, which has shown temperatures near Sacramento on and off of like 125 degrees Fahrenheit, which, again, to be really clear, is not going to happen in Sacramento or anywhere else in the Central Valley during this event. Nonetheless, there are going to be a few places that make it up into the upper 100 teens. So it is possible that places like Redding get up to 117, 118 during this event, and places like Sacramento get up to 112 or even 113. Fresno kind of in a similar range. These are generally temperatures that are within a few degrees of the hottest ever observed in these areas, and frankly, within the margin of error, we can't be sure that we won't hit those new records. So kind of plus minus 2 or 3 degrees Fahrenheit at the peak. We're now within 2 to 3 degrees Fahrenheit of some all-time record high temperatures in some of these, even these very hot Central Valley cities. So there's a couple of places where this is more likely than others, but there's at least a 10 or 20% chance that some spots hit all-time records during this event, which is particularly consequential because it isn't just a one and done, a very hot day and then it's over. But this is a very long duration heat wave in which some places may get in within a few degrees, if not tying or even breaking their all-time records. Again, this isn't going to happen everywhere. San Francisco is not going to break its all-time record, nor is Los Angeles. But across some of the inland areas, places where frankly the heat is already more intolerable, this is going to be a genuinely intolerable heat event that lasts 4 days. A couple other places that could come close to their all-time records, places in the lower deserts. Palm Springs could get up into the low 120s, and I believe that the highest temperature ever recorded there is about 123 degrees. We will get close to that during this event as well, so especially during the latter half of this event as some of this heat shifts a little bit southward. So pretty much everything is on the table. I don't think I've ever seen an excessive heat warning from the Weather Service in the Bay Area last for a full week or more, and the red flag warnings are slated to end on Friday. Doesn't mean that the fire risk is going to be low beyond Friday. It just means that the combination of extreme temperatures and strong gusty winds will decline somewhat probably by Friday, but will be somewhat offset by the fact that fuels and vegetation will be even drier at that point than they are right now when we're already seeing some problematic fires breaking out. On top of all of this, of course, is the fact that Thursday is the 4th of July holiday, and as I pointed out in my recent blog post, there was an enormous spike in human-caused fire ignitions within about 24 hours on either side of the 4th of July because primarily, as you guessed it, fireworks, unauthorized firework displays, to put it politely, illegal fireworks in most cases, given where they're let off and given how few places allow you to do that in California for obvious reasons, or at least reasons that should be obvious. It should be painfully obvious this week, and I really do hope that people are able to contain themselves during this very high fire risk, potentially historic heatwave event, but it seems almost inevitable there will be an increased pace of wildfire ignitions leading up to the 4th due to the combination of fireworks and this is the reality that there's a lot more people outside on the landscape doing things that can potentially generate sparks, whether that's campfires or grilling or fireworks or any number of other things. Just being out there in the landscape, frankly, even driving a vehicle out into the wildlands. You know, if hot portion of the undercarriage comes close to grass, or you get a flat tire and you drive on the rim, or any number of things that can go wrong. More people out on the landscape at this time of year during the holiday, more ignitions. There probably are going to be a high number of new fires in California that ignition rate will likely spike right around the 4th, as it does essentially every year, even when fire conditions are not particularly extreme, which they are not every 4th of July in California, but they certainly are this year. So this heat event, as I mentioned, is actually also going to be broader in scope than originally anticipated. Record high temperatures in some places up in Oregon are now looking to be a possibility. In places, even some parts of the interior valleys in western Oregon could even get close to 110 degrees, which until the record-shattering, historically unprecedented, mind-blowing heat wave of June 2021 had never happened before in that part of the country. We're not going to break those June 2021 records up there, thankfully, but the fact that this heat wave could actually get pretty close to being the most extreme heat wave up there but for that event, which again was in June, so there might still be some July records threatened up there, is just an incredible testament to how much things have changed in a warming climate. And again, just to reiterate, we know that climate change is increasing the frequency and the severity of heat waves like the one that California is currently experiencing and is going to continue to endure for the next week. It's unambiguous at this point. Scientific studies can help us tell exactly the degree to which this heat wave, or other heat waves, perhaps is worse or more likely due to climate change. But it's a significant influence, and it makes heat waves of the magnitude that we're observing right now far, far more likely. We're talking about most studies suggesting that most record-breaking heat waves we see today are dozens or hundreds of times more likely to occur at the extremity that they did because of climate change to date. And of course, the climate is continuing to warm, so if you ask that question about what will things look like in 10 years or 20 years or 50 years from now, that number will be even larger. And makes me wonder, what the extreme heat events of the 2030s and the 2040s and the 2050s are going to look like because of what we're seeing now. What are the record-breaking events of 2047 going to look like? And I think that, the theme of the week in so many respects is, I guess, worse than expected. Not just meteorologically, but in many other ways. But I think that, the real challenge with predicting the future is it hasn't happened yet. And sometimes we have systems that are predictable, as is the case to a large extent with weather systems. We have done a pretty good job, I would say, predicting a highly anomalous long-duration heat wave with this event. This was something I started talking about at the beginning of last week, so it really showed up in the model ensembles quite far in advance. Difficult to pinpoint exactly how intense and how long it was going to be until it became closer out, but this was not something that came out of nowhere. It's another predictive modeling success. It's alarming in that it was correct, but at least the models were largely right about this event. There were some issues, as I mentioned, with the surface temperature output from some of these individual models being far too hot. This is a known issue, but interestingly, it does not seem to greatly affect the overall representation of these heat waves. This is really just a lower boundary problem that hopefully gets adjusted soon, but really the gist of it is that the prediction for this event there was a lot of early warning, I guess is what I'm trying to say. And now we're here. And now we're in the thick of things, and it's going to last a while. So I want to share my screen a little bit. I'm going to show some different things related to the wildfire activity and a few other topics of interest. I think the first thing you're going to see is live camera footage of a fire near, I believe it's the Thompson Fire, near Oroville, the town of Oroville in Northern California, near the Oroville Reservoir. I believe this might be the Thompson Fire. Yeah, I believe that's what it's called. Just trying to make sure I'm getting my window aligned with everyone else's. This camera view, well, you can see the smoke, of course. It's a pretty significant fire. There are evacuations in and near Oroville. Let's see if we zoom out to the other cameras in the area. Here's another perspective on the same fire. You can see there is the lake Oroville in the lower left. You can see this fire has already made some progress. You can tell where the winds are coming from the right of the screen to the left, so that's roughly from north to south. You can see that this fire is burning on multiple flanks and has jumped different arms of the reservoir, so there's clearly spotting. I'm going to pull up the Watch Duty app just to take a look at what's going on. I know I've been a bit of a app-based wildfire information skeptic until recently. I do think the situation has improved in several ways. I will actually have a session on that later. But I do think that Watch Duty is a helpful resource at this point because it is really difficult to get this information elsewhere in a consolidated real-time way, and I think that Watch Duty is doing an increasingly good job of doing that, even though it's all volunteer-based and informal. It does appear to be a more reliable source than anything else that currently exists. So I'll talk more about that later, but right now I just want to show folks where that is. Yes, it's the Thompson Fire, and it's burning immediately adjacent to Lake Oroville. Of course, some of the north and east side of the city or the town of Oroville are subject to mandatory evacuations already. So this is burning at least near the wildland-urban interface, if not in it at this point. Sounds like there is ongoing spotting. Sorry, this information here on the right is for a different fire. Let me just make sure I'm getting it for the right one. Here we go. That's right. So there's a lot of evacuations that have expanded over the past couple hours. The winds are pushing this towards town, so from north to south. And so this is going to be a fire that probably poses a problem beyond today, so at least into tomorrow. And then if you zoom out, there are a couple of other fires. There was a fire in northern Sonoma earlier, or maybe it was, I guess it was northern Napa County technically. Which side of the county line is it on? No, sorry, that's in Sonoma. But no, it's in Napa County. Anyway, I think it's slowed way down. This one is not posing an immediate threat. There is also the Moccasin Fire on the western slope of the Sierra. It sounds like this one is still active and has some spotting. There are some evacuations. It isn't huge yet, but this one has room to grow. There's another fire up getting close to Yosemite. So this is in Tuolumne County. And then as well, there are the ongoing lightning fires down in the central and southern Sierra foothills, the Basin Fire, the Flash and Bolt fires. These were from that lightning event a couple weeks back. These fires are burning actively right now, although they're already a known quantity at least. Another new fire today, I think it's called the Airline Fire, down, I think it's technically in San Benito County, south and east of Hollister. This one is taking off, and I'm guessing this one has the potential to go big because there probably aren't a lot of resources available already. We're already seeing resource drawdown. This one is somewhat far from major populated areas, at least where it's headed, so this one might not be getting as many resources as some of the other fires. That's what things look like right now. There are likely other fires that are popping up. But let me jump over to satellite right now just to show you what these look like, and I'm going to use my drawing tool briefly to show all right, here we go. So the fires we've got, this is the Thompson Fire, this is the Airline Fire, and then these are these other West Slope fires, Sierra Nevada. So you can see them showing up on infrared satellite. The big one right now is definitely the Thompson Fire. You can't see anything up in Sonoma County, fortunately, right now. But you know, these are some significant hot spots that all have the potential to grow further under hot, dry, windy, and in some cases red flag conditions, and I would expect to see others pop up over the next couple of days. Let me switch over to visible satellite and zoom in a little bit, and you can see that the Thompson Fires, oops, this is a little bit too far north. The Thompson Fire is already generating a significant amount of smoke. So this is the smoke blowing southward, as you can see, transported by the winds. Here's the Airline Fire generating a fair bit of smoke as well, with smaller amounts of smoke from these West Slope fires right now. All right, so let's see what else we've got going here. Going back to the heat for a moment, I wanted to show folks just how much this is going to affect a broad region, not only in California, but throughout a pretty good chunk of the West. This is a database of where temperatures are expected to be near or above record-breaking levels for the date. Stations within 1 degree Fahrenheit of the daily record. And by the way, the current snapshot is for today. So you can see that, yeah, it's hot. There's a few stations in California, Ukiah and Sacramento Executive Airport, that are near or potentially close to records, but there aren't that many. But look what happens as we go through the week. Tomorrow, it gets worse. There's a lot of 110s on the map, places that are within a degree of breaking their temperature, record temperature in the 110s, notably Ukiah, 113 potentially tomorrow. That is very hot for Ukiah and Mendocino County. Then Thursday, the 4th of July, actually there's a little bit of cooling. Some places may drop below 110 briefly, although that's a cold comfort when Sacramento is still 108, Fresno is still 109, Ukiah is still 110, and of course this is Redding. It starts to get even hotter with a 114 in there, along with some 110s up in the high desert down by Palmdale, which would be a record even for Palmdale. And then things get worse again. On Friday, records all the way from the Olympic Peninsula in western Washington, with temperatures right along the immediate coast, all the way up into the mid-80s. Temperatures around Portland and in the valley between 100 and 110 degrees, so really hot west of the Cascades. Look at Redding. 118 in the forecast for Friday. That is extremely hot and likely to become close to the all-time record there. Ukiah back up at 112, seeing a lot of 109 type temperatures down in the Central Valley, and then Palmdale gets up to 114. Palm Springs gets up to 120 or potentially even a little bit higher. All of these, all the way from western Washington to Phoenix, within a degree or so of the record for the date. And then Saturday, in some places, again, looks even worse. We have Redding up at, again, 117. And frankly, again, all of these numbers are really, especially as we get a few days out, are plus or minus 2 or 3 degrees. So we're within spitting distance of the all-time high in Redding. Back up to 112. And Ukiah back up into the 110s in most of the Central Valley. Fresno gets up to 113, which is also close to the all-time record for that station. Palm Springs stays up around 120, within a couple degrees of the record. And then we have places like Reno, up at 104. That's really hot. Reno is at a pretty high elevation to be that hot. And then, additional, even warmer up by Portland. Additional, another day of temperatures between 100 and 110 up there. Near Seattle in Olympia, getting close to 100 degrees. These are exceptionally hot temperatures, and what's notable is you see records all the way from the Imperial Valley, not a cool part of California, but still seeing some record high temperatures approaching 120 all the way up into western Washington. So a very large area with temperatures exceeding 110 degrees, potentially all the way from Oregon down into Mexico and Arizona. Sunday, slightly fewer regions experiencing record-breaking temperatures, but again, we still see places like Fresno at 112 and Redding up at 113, maybe a bit of a break by the Bay Area and Sacramento area, but this heat actually expands eastward with records now up in the east of the Cascades, eastern Washington and Oregon. A further slight ramp down on Monday, but again, this is not incredible relief. It's still 112 in Redding on Monday. It's still near 110 in the San Joaquin Valley, Madera, Fresno. Still record-breaking or near record-breaking temperatures down in Palmdale, Palm Springs, even in Phoenix. Again, and in Las Vegas. This would be close to the all-time record in Las Vegas on Monday. So again, none of these are cool places. I'm pretty much talking about, for the most part, quite hot places that are going to certainly be breaking daily temperature records, possibly breaking July monthly records, and even in a few cases getting pretty close to their all-time record. This chart does not go out beyond Monday, but if it did, there would be even more days of predicted record-breaking heat after it. Those are daytime highs, but I want to show you what the overnight minimum temperatures could look like during this event. Starting on Wednesday, we see lows like 75 degrees in Sacramento, so the temperature will never reach lower than 75 degrees in Sacramento. Low temperatures near Long Beach, 70 degrees. That's pretty tough to achieve in Long Beach because you're right on the water, so that's really warm. And then things get even a little bit more dire with overnight low temperatures in the low 80s down by Bakersfield. Even up in places in Mendocino County, Ukiah might not drop below the low 70s for several nights. Places like San Jose may not drop much below 70. These are not typical values, and we see the expansion as we go into Friday. Look at all these places that might not. I mean, it really across most of the West, equal opportunity to break low temperature overnight minimum temperature records, meaning that the nights don't get as cool as they should, all the way from western Washington down to the Mexican border. That continues Friday into Saturday, again seeing large areas that don't drop below 70 or even below 80 degrees in some places, and this continues even into Monday in some places and into the Great Basin at higher elevations. The last chart I wanted to show here is a prediction of the geopotential height anomaly map and normalized. This is units of standard deviation, so essentially the more red it is, the more unusual it is, and this is a measure of how thick the lower half of the atmosphere is, which in turn is an indirect measure of how hot the lower atmosphere is. So the more red it is, the more unusually hot the lower half of the atmosphere is. You can think of it that way. And here is the present analysis. You can see the ridge right now is offshore. It is not centered over California, but over the next few days, it gets closer. It comes, in fact, right overhead. So the center of the ridge axis is going to be not too far west of Monterey as we get into the 4th of July. So centered over the Bay Area in Northern California. And then you see the secondary strengthening of the ridge as we go into the weekend. So it gets even stronger as it moves directly overhead, with extremely anomalous geopotential heights all the way from Northern California up into the Pacific Northwest. And then it just kind of sits there over the weekend while very gradually weakening. Again, now we're at next Wednesday. We're more than a week out, and this ridge is still there. It's not quite as strong, but it's still unusually hot. And then, at least right now, on the ensemble average of the European model, it looks like this ridge could actually considerably re-strengthen again by the end of next week. So this would be the third wave of the heat wave. And as we see, a lot of California would end up under the gun. This one might favor Southern California more than Northern California on this third round of the heat wave, which may fade away by mid-July. But keep in mind, there's no blue on this map anywhere. There's not really even any white. And what that means is that the warmth of the lower half of the atmosphere will remain anomalously high for the foreseeable future. There's really no end in sight. There's only modest reprieves, mainly across the more coastal zones. This is going to be a very long heat wave. A brief snapshot of that fire up by Oroville one more time before I come back, and you'll see my face again. All right, so that's sort of what things are looking like from the 30,000 foot view. I guess we zoomed in a little bit as well and talked about some of the details. I think one thing that's important to realize is that we often underestimate just how serious heat waves are. Heat waves kill a lot of people. In fact, there is reason to believe that heat waves are probably the deadliest weather event in the United States. So you might think about wildfires, at least a weather-adjacent event, or tornadoes, or floods, or hurricanes, or something like that. But no, it's heat. It's heat waves. More people become ill or die as the result of severe heat than from any other kind of natural hazard in this country, and this is precisely the kind of event that is dangerous. The only saving grace in California is that most heat waves are not particularly humid heat waves, and I think that's fair to say that that is one mitigating factor with this event, is that it is quite dry, although of course that does increase the wildfire risk associated with this event. But nonetheless, even if it's a dry heat, if it goes on and on and on for 7 to 10 days and it doesn't cool off at night, it's still going to get to you. And so it's really important to have access to overnight cooling, which I know not everybody does, and the environment isn't going to give it to everybody in this event, because there's just going to be so much accumulated overnight warmth, particularly in the hills, where you really might be able to open the window at 3 o'clock in the morning and get a blast of hot air. So this is an event that I think the messaging from the Weather Service has been appropriately elevated. I know the National Weather Service has become a lot more cognizant of the heat-related hazards and the associated messaging in recent years. In fact, there's been a push this year to really emphasize, to develop more formal standards for issuing these heat products, these heat advisories, and these excessive heat warnings, like the ones that are in effect right now for most of Californians. Because it is recognized that, in fact, this is really one of the most important kinds of extreme weather events to warn people about, because it is the most likely kind of event to harm you in a very tangible way. And so staying cool, of course, is important. That is easier said than done for people, and depending on their circumstances. And this may be true, in fact, even for people who normally have the favorable circumstances for cooling, because there may be power outages, some of which may be preemptive by PG&E to shut off the power to prevent wildfire ignitions. We know they're already doing that in some spots, but there could also be other power outages. We know there's power outages right now in and near Oroville that are not related to the public safety power shutoffs, but they're occurring because the fire that's burning there was causing the high tension power lines to arc to the ground. So they had to shut them down, and of course de-energizing those means that some people may lose power. We could see more of that. There could also be very large spikes in electrical usage as people use that air conditioning during the peak of the heat event, particularly as there is little break overnight. I am not aware of any electricity generating shortage emergencies that have currently been declared, but there is going to be very high usage in California and the West this week, and there may be some transmission-related issues due to wildfires, and so this is a potential issue as well that may cause some people to lose access to their cooling, which becomes progressively more dangerous the longer this heat wave goes along. And one other thing I wanted to add, although I almost hate to say it, is that one mitigating factor in some of the peak temperatures later in this heat wave is potentially, if we do really get a lot of large wildfires that generate very large smoke plumes, we've seen this before, it can attenuate the amount of solar radiation that makes it to the surface and therefore decrease the surface temperatures. So it's a sort of a I hesitate to call it a silver lining, because it probably means that the fires really got out of hand if that happens, but that has been known to occur before. So if it becomes extremely smoky and dark as a result of large wildfire plumes, it is possible that some of the extreme heat won't come to fruition. But that's never a fun thing to talk about, because it often means that some very bad things have happened elsewhere. So fingers crossed that we don't see any destructive wildfires this week, although there are probably going to be a lot of ignitions under pretty adverse conditions, along with high potential for an elevated number of human ignitions. So please don't be stupid, and this would be a really good year to just not light off any fireworks at all. That would actually be a very helpful, constructive thing that people could do during this extreme heat and potential fire risk event. So I'm not going to talk about the longer term, meaning later in July or August, because that's getting a little bit ahead of ourselves. To remind folks, I probably will have a couple more of these sessions this week at TBD times. They probably won't be hour-long sessions for the most part. They'll be shorter so I can save my voice. Speaking of which, give me a second. So I may try to have several, say, 30-minute sessions at strategic times, depending on how things evolve, and depending how my paper revisions go. I'll try and sandwich them in between there. But I do want to take a look at the questions. So I will be going through those next. And just a brief reminder before I go through the questions, there are a number of ways you can support the channel, the easiest of which is probably just subscribing to the channel and sharing it with others as you feel appropriate. You can also support Weather West channel through Patreon as well as the Buy Me a Coffee website. I'm not sure I'll ever be comfortable with some of the social media tactics to drum up support, but if that's what it takes, that's what it takes, and I'm always grateful for the support, the generous support of folks who follow Weather West, both this channel and the blog and my other work. It really has made a difference in terms of all the necessary software subscriptions and website hosting and the physical hardware. I'm streaming to you today from a laptop that was purchased directly from subscriber contributions. So thanks for that. All right, let me take a look at the questions that are coming in here. There is a question, the first question of the day, which although it's a little bit unrelated to California right now, I'll allow it and answer it because I think it's interesting and at least peripherally related. Can you please explain how after a wildfire, severe storms can develop over the area, like the recent New Mexico events that caused the flooding and debris flows there? I suspect this is related to the catastrophic debris flow and flash flood events that have unfolded in and near the town of Ruidoso in New Mexico following the catastrophic wildfires just a couple of days prior. One thing I wanted to clarify is that these severe storms and flash flooding that sometimes result or sometimes follow wildfires in these burn areas, they are not always the result of the fires themselves. Essentially what happens is in places that have recently burned at high intensity, there are alterations to the landscape, both in the removal of vegetation, the potential formation of a hydrophobic soil layer if the soil or the material in and adjacent to the soil burned at a high intensity, so literally like a water repellent layer. If a fire burned in the right conditions, the right intensity, all of that allows runoff from, say, a downpour to turn into runoff far faster than it would otherwise, and to cause flooding to a greater extent and more rapidly than would otherwise be the case. So it's not always that the fire causes the storm, it's that the fire sets the landscape hydrologic preconditions to more readily allow for flash flooding if a storm develops. That's the most common case. Now, in this specific instance, and in some other cases, it is possible for wildfires to generate severe storms. We've seen this in California and up in British Columbia in particular, as well as southeastern Australia. There's a process known as pyroconvection, and it literally means convection generated by a sufficiently large fire. Convection in this case being a deep, moist convective cloud, so a cumulonimbus cloud, or in this case, a pyrocumulonimbus cloud, so a fire-generated thunderstorm cloud, essentially, that in the California context has most often produced not so much flash flood hazards, but produced more fire hazards. These are often dry thunderstorms. When the pyrocumulonimbi, the plural, in California are often associated with additional lightning. So the fire can generate new fires by creating a fire thunderstorm, which causes lightning strikes that generate new fires. It can certainly generate its own extreme wind patterns, up to and including pyrovortices, which are equivalent to tornado strength. So we know that extreme pyroconvection under the most dramatic circumstances can produce lightning, fire tornadoes, strong winds, downdrafts, all of the kinds of things that thunderstorms can produce. Under moisture settings, then, they can also produce torrential downpours, which you might think is good news, and in some cases it can help self-extinguish fires. So fires that produce heavy precipitation during pyrocumulonimbi can, to a certain extent, self-extinguish. In fact, that is partly what happened in Ruidoso. But, of course, as you might imagine, sometimes that just sets off a chain of events where it might self-extinguish the fire, but also cause a flash flood within minutes of the fire being extinguished. And I think that is partly what happened down in New Mexico, at least on the initial day. There have been at least 3 different flash flood events during that particular situation down in New Mexico on consecutive days, and only the first one would have been potentially generated by the fire itself. The subsequent two flash floods were just the fact that New Mexico does tend to see heavy thunderstorm activity during the summer monsoon, and that has arrived, and so this was monsoonal thunderstorm activity that happened to just hit in the wrong place at the wrong time. Hopefully that's helpful. The next question is about why this year's 110 degrees feels even hotter than last year's 120 degrees. I don't know exactly where the area is. I would posit, I don't know for sure, because the heat, this is not a particularly humid heat, although it might be slightly less dry than last year's extreme heat. But the more likely reason is that this event is potentially hitting very close to the summer solstice. The sun is quite strong and the days are long, so the apparent temperature that your body feels if you're outdoors, or even if you're indoors with some windows that are exposed to the sunlight, is going to be a lot hotter than if that sun is low on the horizon or you have short days. So when we get those autumn heat waves along the coast, they're often a lot more bearable, even if it's 90, 95 degrees along the beach, because the days are short, the sun angle is low, and that really does affect the human body temperature. It may not change the atmospheric temperature as much, but it sure does affect the temperature of our skin if we're outside, or the temperature of the interior of our cars or our buildings if they've turned into greenhouses. So that may be part of it, as this is a heat wave that's coming within 2 weeks of the summer solstice, remember, and so the sun is essentially at its peak annual intensity right now over California, with the longest days of the year or close to it. All right, I'm just scrolling down. Yes, there are a lot of potential sources of wildfire ignitions with people who are spending a lot of time outdoors. I think sometimes people forget. Again, most wildfires in California are human-caused. People often assume that that means that there's firebugs or arsonists running around lighting most of these fires, and that is just not what's happening. It does happen, but it is still pretty unusual and is responsible for a very small fraction of the total number of fires, and even quite a small fraction of human-caused fires, because most of those human-caused fires are accidental human starts. Now, accidental causes can range from gross negligence to something that was a genuine bizarre coincidence that was essentially unavoidable. So there's a spectrum, I guess, of accidental human ignitions, but I would argue that most of them probably fall on the side of, this was something that was, if it wasn't this spark, it might have been another spark, because there's a lot of, and by the way, there's been modern scholarship on how, we live in the pyrocene in more ways than one. Sometimes that's a good thing. The pyrocene means we've lived with fire now for millennia in various ways in society, and fire or combustion, the chemical process of combustion, is responsible for most of modern society. Frankly, it's a key component in the way in every at least until recently with the rise of electric vehicles, it was the way we all got around. It was in automobiles, it was in diesel engines, it was the way we built stuff, factories. Essentially burned stuff, either directly or indirectly, to manufacture things. And I think sometimes we forget that fire is built into even modern electrical systems. If you've ever looked at a light switch, when you turn on, especially older light switches, there's often an arc that will occur, a little flash of light. Whenever there's a spark, whenever there's an arc, there's the potential for fire if there's something that is combustible in the way. And I think we forget just how much modern society predisposes us to potential ignitions. Even as we shift to more electric vehicles or appliances that are battery operated, there are still sparks. Things can still spontaneously combust, even though we try our damnedest to make them not to. And so there are a lot of potential ignition sources from humans, some of which are more avoidable than others. And the ones I think we really need to try to avoid are the ones that are almost trivially preventable. And I would classify firework ignited fires, definitely in that category. There's really no excuse. You really shouldn't be seeing firework ignited wildfires, and yet unfortunately, I assume we'll see quite a few this week. All right. As I mentioned, yeah, I talked about watch duty earlier. I'll talk a little bit more about my evolving philosophy on the best and most appropriate ways to obtain information in rapidly unfolding settings. Yeah, I don't have any definitive answers, but I do think my thinking has changed, and my own approach to it, by the way, is has changed in terms of my own information dissemination across platforms. So I actually want to have a devoted session to that at some point this summer, a little bit later down the line. Yeah, and there's been several folks remarking that air conditioning is not widespread in all parts of California. It's more common in the Inland Empire and in parts of the Central Valley, but it's not common still in the San Francisco Bay Area. It's not common on the west side of LA. It certainly wasn't in anywhere I have lived in the Bay Area or in LA. So, this is something that's changing. People are installing it for reasons that are pretty obvious. It's becoming increasingly necessary. But in this transition period, a lot of people don't have access, and there can be a big problem during an event of this duration if you don't have some way to cool off overnight, particularly if opening the window isn't going to help, as it might not for much of this event. By the way, a couple folks mentioning some of the most extreme temperatures. It looks like Death Valley, Furnace Creek, will get up into the upper 120s, 127, 128-ish. That's within a few degrees of the highest reliably recorded temperature anywhere on Earth in recorded history. Death Valley has gotten there before. Remains to be seen if we eclipse the record in Death Valley. That'll happen some year. It may not be this year. But at some point, we'll actually get a 130 degree reading with modern instrumentation there. That's that's not a very difficult prediction, although I don't necessarily think it'll happen during this event, although again it's within that 2 or 3 degree margin of error, so it's certainly not impossible. Craig mentions that Redding already shattered its hottest minimum temperature record this morning, 83 degrees, did not get cooler than that, potentially a portent of all-time record high this week. Yeah, I mean, even the official Weather Service forecast is 117, 118 on a couple of different days even, so it's actually possible that Redding ties or breaks the all-time record on more than one day during this heat wave. Terry mentions that the California Independent System Operator, the Cal ISO, then did declare a transmission emergency earlier today, electrical transmission emergency, presumably through midnight due to wildfire risk. Supplies are still inadequate, so there you go. This is something that's unfolding, and I would be surprised, actually, if that was the last one declared this week. Yeah, there's a comment about the Death Valley situation. I actually just covered that. I didn't even see that comment yet. But yes, I don't necessarily think it's going to hit 130. But it could, regardless of what the official forecast does at this moment. Since it's always, the last couple of degrees are more an art than a science in some ways, because we don't necessarily have the ability to resolve the variations at that very fine scale. Yeah, thanks for the words of support, folks. Yeah, I am always surprised that there isn't more interest from industry to talk about some of these things in the insurance sector. I do work with some folks in the insurance sector, actually outside of the United States, but there has historically been less interest. within California for some reason. I'm not quite sure what to make of that, but I do engage with folks in the private sector. I increasingly think that that's an important part of my role, even as a public sector scientist. So, if there's anyone out there who wants to chat, I'm all ears. I'm very easy to find and reach. Let's see. Yes, as I mentioned earlier, the Weather Service is really taking the messaging surrounding heat seriously. And there's been an important, I think, this year policy implementation of more strict thresholds for the issuance of these warnings, stronger language in public-facing products. And I think all of that is justified for two reasons. One is that even if there were no climate change and global warming, we probably were understating the risks of the heat events that occurred in the past, in the 20th century. And, of course, in a warming climate, they are getting worse. The risks are actually higher. So they were underestimated to begin with, and they're higher today than they were decades ago as well. And they will be higher still in a couple decades from now. So I think that it's a good thing that this messaging is becoming a little more standardized and a little clearer, given what is at stake, which is quite a lot, actually. Paul mentions it was 85 degrees in Winters this morning. I don't know if that was the official overnight low, but there are going to be some places that just don't get much below that kind of temperature for a week. And then Tyler asks if I can speak about the wet bulb temperature reading and its significance to human health. I actually just talked about that. I can't remember if it was in yesterday's session or the one last week. So I would encourage you, I think it was last week, please check that out. I talked about it in some detail. Long story short, the wet bulb temperature is a measure of essentially of how easy it is for evaporation to cool the air. If it's very humid and very hot, you can't really evaporate enough water to cool down significantly. If it's very hot and very dry, if there's enough water available, you can evaporate a lot of that water and cool down quite a bit. In the context of this event, the good news is this is not a high wet bulb temperature heat wave event, unlike the events we've seen recently in the Middle East, in South Asia, in India, in Pakistan, Bangladesh. What's happening in California is a low wet bulb temperature, but extreme dry bulb temperature event. So it means that sweating is essentially still very efficient. That's why it's such bad news from a wildfire perspective, because sweating is efficient because the air wants to evaporate a lot of water off of your skin, which is good if you want to cool down, so it does help mitigate the heat impacts to health somewhat. But it actually makes things worse from a wildfire perspective because it's going to increase the evaporative demand of the atmosphere, extracting more and more and more water out of the landscape, out of the living tissues of plants as transpiration, out of the ground surface passively as evaporation, and also, of course, out of lakes and rivers and reservoirs and standing water as directly as evaporation at increasing rates as well. That is something we're seeing also increasing in a warming climate, the evaporative demand of the atmosphere, which when I hang up on this live stream, I'm going to have to go back editing the manuscript, talking about how in the western U.S., the observed increase in the evaporative demand of the atmosphere, or the vapor pressure deficit is another quantity related to that, has been increasing even faster than climate models suggested that it would. So there was agreement that this quantity should be increasing over time. But in the western U.S., as well as in some other semi-arid regions in the world, it's been increasing faster than we thought it would for the largely correctly predicted level of warming to date. So stay tuned for some more updates on that front in the months to come. But for now, stay safe, stay dry. Hopefully not too many folks are affected by fires this week, but I suspect that the folks who are under evacuation orders tonight will probably not be the last ones this week. So I do think that Watch Duty app is helpful. And by the way, I do not have it on my phone. I use the web version of it, and I'm grateful that that exists because it's actually a bit of an accessibility issue to only have it available on smartphones. I was sharing with you today the web version. So that is one way to keep track of the fires as they unfold. as social media has become a bit fragmented. I'm not seeing, there is still some information on different sites about different fires, but it's often not all in the same place at the same time. That is probably the most singular coherent source. I will also note that the CAL FIRE website, the real-time map, is a lot better than it used to be. It still isn't quite as up-to-date in most cases as social media or watch duty, but it's a heck of a lot closer to real time than it was, say, back in 2015 or 2016 during the fire events that occurred at that point in time. So I do think it's a helpful resource. I think things are moving in the right direction with that. Let's chat about that in another session. Stay cool, stay safe, and probably see you again either tomorrow or the next day for yet another pop-up Weather West Heatwave edition live weather and climate office hour. Thank you, and I'll see you next time.